Alright, so in our unit, we've been recently looking at histograms. So one of the ways of when we describe some type of distribution, we use this acronym, SOX. So let's go in and see what we can answer based on what's given in this histogram. So the first S stands for shape. If we look at the shape of this histogram, it kind of starts out small here, goes up high, and then comes down just slightly. So whenever we have this non-symmetric look and it's kind of being pulled to this side, we call that a skew to the left. So this is going to be skewed left. And we can have a strong skew or a moderate skew or a slight skew. You can use those adjectives to describe how strong that skew is. That's a K right there. The O stands for outliers. There doesn't appear to be any, so I'm going to just go ahead and write none. The center I'm going to skip, and we're going to talk about that next. But first I'd like to talk about the last S, which is spread. So the spread that we talk about right now is the range. So the range is given by the max value minus the min value. And in a histogram, we're just going to take the two endpoints. So in this case, it's going to be 100 minus 40, which is 60. So our range, in fact, is about 60. I'm not sure if I have a score that's 100 or I have a score that's 40. So I'm going to use that approximately symbol. So it's approximately 60. And if we want to talk about test scores in percentages, approximately 60%. All right, so the center is a little bit more difficult to follow on this one. So one of the things that we can find, we can actually calculate this because of the information that's given right here. So if I wanted to calculate, let's say, the median, what I'm going to look for is the middle number. So I need to be able to read what information is being given here. So this right here represents one kid scored between 40 and 50. One kid scored between 50 and 60. Right here we have two kids, and I'm pulling those numbers right off the sides. So we have two kids scored between 60 and 70 and so forth. So I'm going to go ahead and fill in the rest. There are 4 kids here, 5 kids scored between 80 and 90, and 3 kids scored between 90 and 100. All right, so the median is the middle number when all the numbers are put in order. So when I look at this, I have 1 kid here, 2 kids here, or 1 kid here, 2 kids, 4 kids, 5 kids, 3 kids. If I add that all up, this comes out to be 16 kids were tested or represented in this histogram. So if I look at the number, so we have 16 kids. Half of 16 is 8. So I want half of my numbers on this side. So I have 8 kids on this side, 8 kids on this side. So if I think about the position of the median, it's between my 8th and 9th kid. So I'm going to count my way over. 1, 2, 3, 4, 5, 6, 7, 8. So my 8th kid, 8 kids fall that side, 8 kids fall that side. So my median's actually going to fall right inside there. So because we don't have any actual values here, my median's going to be about 80. Now, one of the things that you've talked about today is you said, hey, if I know where the median is, I wonder where the mean is. Well, what the mean does is we're looking for the balancing point. So if I had to figure out where do I put my finger to balance this, if I put it right where the median is, I have this feeling that it's going to kind of tip over in this direction. So what I need to do, or actually it's going to tip over in that direction, what I need to do is actually slide this over slightly. Right? So my median, whenever I have a skewness, the median stays there. The mean tends to get pulled towards the skewness. So the mean is going to be a little bit to the left. I'm going to say it's about 78%. This is not definite. It's just where I guess my approximation is. I think it's going to be a little bit to the left of the median.